Okay, so hello everyone. Today we are at this HPC AI parallel GPU workshop, and what what we'll be doing is basically okay. Let me first do one thing. I will keep all the resources in one uh, GitHub account that we will that we will make for this, and I will just paste what are our objectives. Okay. Yeah, so I'll just HPC AI uh, parallel AI GPU workshop. So this is going to be the repository for this workshop, and okay, let's create a README. Mm, and the tasks, these are the three final tasks that will be achieving in this workshop. This has been so Hassan and the group at Bureau of Economic Geology has been very helpful in getting this running, this workshop. And there I I I realized that a lot of people would like to run their deep learning codes on GPUs, and this is the final goal. So how do you train deep learning models on multiple GPUs with Apptainer containers? So the first step is like those of you, I think many of you are must be familiar with VS Code. Those of you who are not, so Cursor is a great uh, fork of VS Code. So the first thing is first thing that you do is that you get the remote SSH installed on your VS Code. You'll get that in the extensions, and then go to so you can see this SSH as an extension here. So you just add in this case. So what I'll be doing is, so we have the Texas Advanced Computing Cluster at UT Austin, and we have four machines here: Vista, Frontera, Stampede 3, and Lone Star 6. So Vista has the H100 GPUs that we will be using today. For those of you who have account on TAC, uh, you can basically follow along with me, or you can I'll be posting this as a recording, so you can go back and look at that as well. So Vista is the machine that we will be using, and I was talking about, so you have the extension, you add the remote SSH. So I will just log into my account. I hope my screen is visible. If the text or the font is small, let me know at any point in time. And okay, so we'll say connect and then continue. And okay, so it will ask you for a password. And then so those of you who are working on tag, you might be knowing that we have to put the tag token here. So you just have to do this the first time. Like this password and token you have to enter every time, but then I'll just shut this down and show it to you the next time, like the second time when you are doing this, how you would basically run VS Code on the HPC. And okay, so it's basically it's saying it's opening remote. Let us wait for that. Asking the password again. I think there. Uh, okay. So there was some issue with the latest version of VS Code. Uh, what we'll just do is alternate way that you can do is you can basically start a terminal here. You can just directly SSH into your machine. I'll just do that for now. I think the recent versions of VS Code was having an issue, and but I think cursor should work fine. So we are inside the uh we are inside the Vista machine on TAC. So you can see that when you log in, you are into the login node. Um, any kind of heavy compute. We had some in-person discussion early this week. So you want to go to the Scratch. You basically do a CDS and you go to Scratch. So the home folder does not have a lot of disk space, but Scratch has almost unlimited. But uh, Scratch will get deleted after 10 days if you don't use it. Now the thing is that when you want to run your deep learning model on TAC or on any HPC, so the thing that you should be familiar with is the NVIDIA NGC containers. So let's see. Okay, so we'll see it for PyTorch. So the thing is that you need Cuda to run any deep learning code, and particular version of Cuda is compatible with a particular version of PyTorch. So if you start running your or installing your own Python environments, you would basically land up in a lot of issues. Things might work sometimes, but like if you do some other pip install, your Python, there's a high chance your Python environment will break. So that is the reason we have this thing called as containers. So container is nothing but you can think of it like a virtual machine in the past. So there used to be this thing called as virtual machine. Lots of problems with that, the RAM issues, and the RAM would get divided. But what what happened some years ago was that this thing called Docker. So you can just go to. I'll not go into Docker tutorial in this session because the goal is basically to run deep learning models on parallel GPUs on an HPC infrastructure. So you can just go to Docker and learn Docker at your end. So that's the step one. And you would need to do Docker first to understand how containerization works. So by containerization, what I mean is that you can basically encapsulate all the like right from the operating system code to your actual code, uh, and then you create a Docker container, make it as a Docker image, and then there is this thing called as Docker Hub. So you would basically push your you would push your images to Docker Hub, and okay, I'll just show you some of the images that I have, and then you can pull that to any operating system. Now, the benefit of doing that is that, for example, I have this image for GraphCast. Now, I built this image on TAC. Let's say TAC is an Ubuntu machine. Now, tomorrow you are working on some other machine, which can be an HPC or some cluster or maybe your laptop. You can just directly pull this image and you can just run things. It will be like an operating system running inside an operating system. So that is about containers. And one way to do that is the Docker is the most prevalent way to do that. One problem with Docker is that you would need root permissions to do Docker. So you cannot get a root permissions in the HPC systems. So for that is the reason uh, we need to have an alternate to Docker. So That alternate initially started with this thing called as singularity. So you can go back and read about singularity. So singularity started as a project for containerization, but wherein you don't need the root privileges. So that is how they started this project. And then I think couple of years ago, Singularity basically became Apptainer. So Apptainer is if you go to the documentation or about us of Apptainer, uh, Apptainer is basically it comes under the same open source software organization as Ubuntu, and it's now the community standard to basically if you want to do containers in HPC. So that if you want to do that, you use Apptainer for that. Now we have Apptainer in all our machines: Vista, Lone Star 6, Frontera, and Stampede 3. So I will just directly start with Apptainer. I just wanted to show you some things before we begin, so that you have an idea of how would you run containers on the HPC. Let me just so I will put all the material in this GitHub repository, HPC Parallel AI GPU workshop, and let me just pull. Okay. So I yeah. Okay. So the first thing that you need to understand is like how the HPC works. I'll just maybe take a couple of minutes on that. So you are in the login node. You would not be running a lot of huge tasks on the login node. So uh, if you are on the login node, the best thing that you would be doing is that basic stuff you can do like copy, move, and basic Python scripts. But if something is high RAM task, you should not be doing that on login node. For that, what we have is are the GH and the for example, the Vista machine, it has got a queue called GG. Now GG has a memory of 237 GB. It has got this local storage. Then you have the GHQ in Vista. Now GHQ has got 96 GB of GPU RAM, and also it has got a CPU memory of 116 GB. So you typically would not work in the login nodes. Uh, if you want to run something, let's say which is GPU based, so you would use the GHQ. If you want to do something which is the high RAM task, you would use the GGQ. And so they are so they have the GG, GH, and GH dev queues, and you can see that they are charged differently uh, based on the. So if it is a GPU queue, it is charged more typically, and if it is a CPU queue, it is charged less. So on Vista, maximum time you can get for queue is 48 hours, and the way to enter into that is so you would use so if you want to do you can do things in two ways. One is you can interactively enter into the okay, sorry, you can interactively enter into a GPU or a high RAM CPU compute node on the machine, and the command that you will use for that is idev minus p. Then you give the name of the queue. Then you ask for the minus capital N is the number of nodes, and then minus small n is number of MPI jobs requested. So in this case, for example, the Grasshopper has just one GPU on each node. So you can just keep these numbers as same, and then you give minus t, which is time. Uh, you give minus t as time, and here I'm giving that as 48 hours. So let us try and get into the grace offer. I hope we are able to get the queue, because sometimes what happens is that it's not available. So we'll see that. So for now, I just requested for one GPU. You can see I've requested for 48 hours. And now interactively, I am inside the GHQ. So you can see that from login dot to dot vista, and it was showing this dollar sign. Now we have changed to C3636152GH. Now, how would you let me know if my font size is okay? Uh, Hassan, is it okay? Is my screen visible?
Yeah, it's visible.
Okay, fine. Thank you. So the way to check if you have a GPU on a machine is this command, NVIDIA SMI. So if you do NVIDIA SMI, you can see that it basically it gives if you run NVIDIA SMI, it gives you this kind of an output wherein you can see what is the GPU RAM available. So in this case, this is the NVIDIA H100 system, and this is about 98 GB of GPU RAM, and this is how much we are using. So that's that's one way. Like we are now uh, now going through how to interactively uh, access the queues. There is also a way in which you can submit the job. If it's a large job, like you are requesting multi GPUs, or you can, when you are working and you are doing a lot of trial and test, that is the time you would basically do things interactively. But then once your code is frozen, you can basically submit a job and just leave and let that thing running. So we'll see in interactive mode right now, because we have more control over the environment. So we saw that okay, you have to do idev minus p name of the queue, minus capital N minus small n. You have to give the number of nodes. You have to give the number of MPI jobs, and then you give the time. So the time for which you can request this queue. Um, so we are in the GHQ. Now you can see that we got this node C3636152. Now to access Apptainer in so what you have to do is you have to do module load tag Apptainer. So once you do this, you will start having access to the Apptainer command line interface. Okay, so we can say Apptainer minus help. It shows us what all I can do with Apptainer. Now, w- if you now you entered the GPU queue, you loaded now your Apptainer is working. Now the next step is I was talking about the NVIDIA NGC uh, PyTorch images, right? So how do you ensure that you get the container? So in this session, I will not cover in the part on how to create your own image or container. We'll just pull the working container from NVIDIA. And the good thing with this is, and these things are pretty heavy. So you can see this is about 12.78 GB. And the good thing with this is that once you are inside the container, You can pretty much do anything and use the GPUs. But we'll see how to do that. So let's say you want to get this particular version. It looks like it's the latest tag of PyTorch on NVIDIA NGC catalog. So I will just say Apptainer pull, and then you paste uh, this one. Uh, so you copy this thing, you click here, and it gives you nvcr.io slash nvidia slash pytorch uh, 25.06. Also, what you have to do is you have to append it with Docker. Okay. So once I do this, you can see that it has started pulling the NVIDIA PyTorch image uh, in my system, and let us see how much time this takes. While this is going on, I will maybe go back to the multi GPU thing that we have. Uh, okay, so yeah. So let us see that. Okay, this is running, and okay. So when you are running so we need this PyTorch image first of all, and then the next thing that I will show you is how to basically use PyTorch and then Apptainer and run your code, your Python or PyTorch code, a very simple code on the GPUs. So for that, what you also need to go back and see is the DDP PyTorch. So when you are running PyTorch with multi GPUs, so why we are right away I'm starting to talk about DDPR, which is called distributed data parallel, is uh, I'm kind of trying to build the basics on uh, we start with DDP with single GPU, then we do DDP with multi GPUs, and then with a very basic Python code, like what we'll do is we will just say, okay, which one is the GPU available, what is the device name, what is the local rank, global rank, world size, master address, master port. We'll just print these things out. If the GPU is working, uh, it will basically first of all it will say GPU available. It will give us a true or a false, and then we'll get to know that things are running on the GPU. So this is the first step that we'll do. For those of you who are not familiar with PyTorch, you will have to actually go through PyTorch first, and then this is where we are starting to talk about the parallel part of this of running the deep learning codes on multi GPUs. So your code also has to be parallelized. You should have access to multi GPUs. You should use Apptainer, and you should basically log in. So you can the easiest thing is you can interactively log in into the Grasshopper uh, by running this idev uh, command. So let us see how much time this takes. If this is taking too much time, I already have the containers on in my Vista account. I'll use those. Any questions until now? Am I audible?
Hi, Manmeet. Yes, you are audible.
Okay, okay, yeah. So uh this is creating something called as SIF file. Now when we are working with Apptainer, it will create this thing called as SIF file, which is the actual container. Because and when you are working in Docker, so Docker, because it has root access, things will go into a particular directory, and Docker will take care of all those things. So when you are using Apptainer, then think like you will have basically more control over the system. Okay, so let me see. Uh, okay, I'll try to get one more terminal and use the zip file that I have. Okay, oh, this is complete. So you can see that I will move this into. Okay. So you can see that I have got this zip file, and what we ran for that was this command apptainer pull. You will get just this one from NVIDIA NGC catalog, and then you have to append it with Docker colon slash slash, and then this is quite big. You can you can see that it is about 12 GBs. So the next step is what I'll do is that okay, let's go to raw, and then what I'll do is I'll just get this code here. Okay. So I have the DDP torch run simple.py, and you can see that this has import OS, then you are importing PyTorch, and you are doing GPU available, Cuda torch is available. We will try to run this simple code uh, using Apptainer on the GPU. So we are already inside GPU. Now to run that, what you would basically do is okay. Let me go to the other part. Yeah. So you would use this command, which is apptainer exec minus minus nv. So minus minus nv stands for the GPU. Then what you do is you give the name of this file. So you say PyTorch, this one, and okay. The first thing that you can do is in the apptainer. So you can basically run anything. You can think of this as a standalone machine or a standalone operating system, which is configured with all the PyTorch, Cuda, and everything it has. So you can just see, try and run NVIDIA SMI inside Apptainer. So you have to do Apptainer exec minus minus NV. So minus minus NV is for accessing the GPU. Then you give the name of the container, and then you say NVIDIA SMI. So you can see that this is running fine. The next thing what I would do is so I can say Python or DDP. So this one, so this is the command. I'm running inside this container, and to run inside this container, we have to give apptainer exec minus minus nv, and then now this is, let us see. Okay, so you can see that it says GPU available true. Device is NVIDIA GH200, 120 GB, local rank -1, global rank -1, world size 1, and master. So this is the master address. So you can see that the uh, PyTorch code, very simple code. Basically, we are not doing anything here. We are not training any models. What we are just saying is we are just trying to access the GPU. We are giving the device name, and then we are just trying to see whether the GPU is accessible or not. That's the step one. Step two. So we will now. Okay. So this was the DDP torch run. Simple and okay. So we have basically seen how you would uh, you would do things interactively, and let's say you want to now do things on multi GPUs. So for doing stuff on multi GPU, uh, what we would basically do is we will let us try to do it by submitting the jobs. So what you can do now, so on a single GPU, because now this code is running. So anything you run, the models you want to train, because now your device name, so torch.cuda.get device name, if GPU available. So GPU available is coming from torch.cuda.is available. This is working. So you can basically start putting your data, your models onto the GPU and then start training your models. Uh, and this is just for a single GPU. What I'll do is I'll exit from here, and then the next thing that we do is uh, I'll, let us see if we are able to get 16 uh, GPUs. Okay, we got 16 of them, and now you can see that we have come here. Now this is the node that we got. This is the master node. Okay, so now if you do here NVIDIA SMI, okay, you can see only one GPU. But if you remember, we requested for 16. So where are those other 15 GPUs? So what you can do is you can do S control, show host names, slum job node list. So when you do this, is so you can see that we have all the 16 nodes. Each of these nodes have an NVIDIA GPU, and they are all there, but we'll have to physically access them. So how to physically access them? What you can do is you can basically do an SSH to a particular node in this case. So I think that time when I was running previously, it was different. So we are on 612.0.0.1. So let's say I want to go to C 612.0.0.2. Okay. So I am on C 612.0.0.2. So this is that particular GPU. So now things start getting a bit like more. You have to take more control of the situation, and you have to physically go and access the different nodes. So if you are doing things interactively, we'll see how you would do things. If you want to submit a job. So SSH 612072, you enter you enter another node. Okay. So you can see that this is now C612072. The the next step is so if you want to run over multi GPUs now, because you have access to multi GPUs, and I'm saying, okay, I'm on this one, but our master was 6120.0.1. So maybe let's go back to the And if you see now those commands, the SSH command is not visible because that was being run on that particular node. So we ran SSH C612072 on C612002. So let's say I go to SSH C612001. Okay. So this is the master that we have. And let's say you want to run on all the four nodes this command NVIDIA SMI. So for that, what you will do is you'll say srun minus n4 minus minus tasks per node equal to 1 NVIDIA SMI. So you can now see that it has accessed four nodes, and it is running from this master node. And this output is coming from the first GPU. This is from the second GPU. Then this one we have from the third GPU, and this is from the fourth GPU. So basically, we have now tried and tested. We are able to access the four GPUs. So you will use this command srun minus n4 n tasks per node. So number of tasks per node. Uh, that that is fine. Now the next thing is, okay, let's say if you want to find out the host names of four, like you have 16 nodes available. So I can also say n8 task. Okay. So you ask for 4, you get 4. You ask for 8, you get 8. You ask for 16, you'll get 16, but not more than that because we requested for 16. So all our 16 GPUs are available. They are working. Uh, this was just an activity I wanted to take you through to familiarize you with how the different, like you can do different things with the multi GPU system. What we'll do now is, preferably if you are working on multi GPU systems and you want to do multi GPU training, you would want to submit a job. So how to submit a job on a HPC? I think a lot of you must be aware of that. So we have Slurm on TAC. On other machines like I worked on the machines at IITM in India. They use QSub. There are other IBM machines which might use different job submission schedulers. But Slum is something that is also very common, is what I've seen. So you can use srun. So srun is the command that you can use. So idev is for interactive jobs. So you can see if you want to access a particular queue, then the number of nodes and number of MPI jobs. And then you can either give minus T and then time in hours, or you can give minus M and time in minutes. So we have srun, we have the command sq. So let's say if I run sq minus u ms86336, which is my username. So you can see that it is still showing that those IDEV jobs, they are running. So you can see that I requested for one node initially, and then these are the 16 nodes. I think it was, yeah, I think we have come out of it, but let's try to kill these jobs. So to kill these jobs, what you'll use is s cancel. So you'll say s cancel, and then okay. So you see this job now is showing it will get cancelled in some time. At least it is not showing running. And then now we'll cancel the other one as well. 059. Okay, so let me just see SQ minus UMS 8636. Okay, so you can see that all the so this one I gave by mistake. I requested for 16 GPUs. So you can see that all the jobs are now cancelled and they are not running. Now, what any questions until now? Naveen, I think you already know all this stuff, but still,
Yeah, no questions.
yeah, okay. Uh, then the next thing is okay. So we will run this script and we will try to test multi GPU on on tag. So this is the job job submission script. So you can see that I have requested for this is the job name and output and error files, and then what you have to give here is your allocation project request ID. So yeah, let me first get this script for testing multi GPU codes. Uh, where am I? Okay, so let us get this code test multi-gpu.sh. So you can see that in this code, the first step that we are doing is just we are trying to see if the GPUs are available. And now we are trying to see if both the GPUs are available at the same time together. The only thing that I might have to change here is my project charts code. So I only have to change with the allocation or project ID here. And once you are done with that, so you can see that to to run a job, uh, so you will have to do IB run, and then this will basically run your job. Uh, and but if you want to if you want to submit, I think the command is sbatch. Yeah. So you have to do sbatch and then your job script. So I have this code test multi gpu.sh where we are just trying to access multi GPUs and see that if PyTorch is running on them. Right now we are not doing Apptainer, so we are just seeing at a simple level whether we can run PyTorch like the simple torch uh, on multi GPUs. So you say sbatch test multi-gpu.sh and then you do sq minus u your username. So you can see that this job has been submitted ls minus lrt and then test. So you can see in the output file it's saying that running on nodes. Now when you check your test multi-gpu.sh, so uh, we are giving an echo here running on nodes and then showing the host names. So you can see that running on nodes, it's giving these two nodes, and then the Cuda devices. Uh, so we are also echoing that. And then we are giving IB run minus NB2. So basically we are requesting for so here you see first of all you have to request for two nodes. I think this can be one number of tasks per node, but here also we requested two. That's okay. But then this one, so the number of GPUs available should be equal to the number you give after np here, and then you give python, and then you can give a python code, or I'm just giving this very simple code on what are the gpus available. So you can see that this is the first gpu available. So first gpu is giving me true, second gpu is giving me true. So both my gpus, they are basically right now for this task, they are uh, they are working fine. And we'll see this out. We'll see the error. So you can see the error, and it's not giving anything uh, which is serious. So you can see that we have now run we have now accessed the multi GPUs. Uh, the next step is basically, let me go back to, yeah. So the next step is test multi GPU. Okay, we'll do this. So test multi GPU on Apptainer with DDP and simple torch run. So what we will what we'll say is that, okay, this we request for two nodes, but then can we run the on as a first step on a single GPU, the DDP torch run simple.py code. So you can see that DDP torch run simple.py is here, and we'll try to run it on, submit it as a job on on a single uh, on a single GPU, and then this is where we try to run on a multi GPU. We submit a job. So okay, I'll I'll get this code. We'll paste this because we first the code test multi gpu.sh, it just was able to give you uh, access to multi GPUs. Now we are using Apptainer on GPU and submitting it as a job. So I'll make this runnable. Okay, so you can see that so everything uh, remains the same. And I have this Apptainer multi GPU dot sif uh, already built. You can use the PyTorch dot sif as well. And what we'll do is here we'll just change the project charge code, which is okay. And we'll submit this. And now you can just check whether your job is running. Can do a tail minus f Okay. So you can see that the two GPUs are available. So global rank 0 and global rank 1. So for each GPU, now we are actually entering the MPI domain. So you can see first multi GPU, Apptainer, DDP dot simple. So it is what it is doing is it's launching two tasks in this loop and giving this is the local rank is 0, and then it is also printing out the global rank, and that is happening from inside the DDP torch run simple.py. So you can see here the local rank, global rank, and it's true, so it's working for me. So we have now seen how to access multi GPUs using Apptainer. One thing that I wanted to emphasize was that okay, uh, you need to be careful in making the container as well. So when you are making the container, uh, yeah, I think I have not put here. Let me just go back. So when you are making the app multi GPU container, what you have to take care of is uh, if you are using torch harmonics, and so you have to use this def file, and then with def files you can basically make a container by saying def apptainer build uh, something file dot sif and then file dot def. This will make a this will make a zip file for you based on the def, and then the definition file, you can see basically it starts from a particular already built uh, image. So here, for example, we are starting with NVCR NVIDIA. So this is from the NVIDIA NGC catalog. You start from here, install all these things in that, and then build a zip file on top of that. So we have seen how to use individual GPUs on and containers on the tag system, and the GPUs are available. It is showing true. I think it's 10 a.m. now. So should we maybe do one more session, Hassan or Naveen? And also it gives time for everyone to maybe go back and try and test things at their end. And then next session I can take the how to train the models. What do you say?
Yeah, that will
Yes,
be good.
Okay. Yeah.
yes, I think it would be better for us to and others to a little bit
Yeah.
test.
Okay. Yeah.
Uh,
I
I
have
have
a
a
question.
question.
Yeah, Naveen.
You were showing that here we have only one GPU per node, right? So
Yes.
if we have multiple GPUs per node, does this method work, or should we
Yeah,
modify
so
anything?
I have not yet uh reached the point where you would be doing DDP plus
Mm,
Apptainer
mhm.
plus multi GPUs.
Okay.
When you do that,
Yeah.
PyTorch takes care of all those things. The only like why I'm showing this step by step is because when I was building this, or trying to do this, I face problems at every step, like
Yeah, I know.
getting access to two GPUs, but then only one GPU was giving me true, others were
Yeah.
giving false. I,
Hmm.
like I was having the hardware, but I was not able to run code on those.
Yeah.
So that is why I was going through these. But eventually the torch.ddb will take care of everything.
Hmm.
So you don't have to worry about that.
Yeah.
Yeah.
So we have discussed this before. That's why I was asking this. If you
Yeah,
have
yeah,
you
yeah.
found this? Or, yeah.
Yeah. So I think that should be fine. That's not a
Yeah.
problem.
Okay.
Man. Yeah. Is there is there any other question or comment or feedback?
Yeah. This like in the next session, what are you planning to do? Like, will uh,
What I'll do is I will start with uh training deep learning models on a single GPU and
uh-huh.
then multi GPU. I think we have covered enough basics today.
Yeah.
Yeah.
So
Just these two things are
are
remaining.
are you planning to put that in the GitHub beforehand so that we can go through
Okay, yeah.
that before? Yeah.
I'll do that. Yeah. I'll do that and maybe send an email with proper instructions or I'll put the details in README.
Yeah, so that it will be helpful. Like we can follow
Yeah.
you at the same time. So
Yeah. Sure. Yeah. Okay. Thanks. Yeah. Okay. Any other thing? Okay, I'll just stop the recording.